Hello, challengers. I'm happy to have you here again in this weekly live. Just to remind you, this live happens every Tuesday at 10 p.m. London time. And today we're going to be talking about the system design interview. We're going to be talking about the strategies we need to apply in these interviews so that we can pass in this interview. So obviously you need some knowledge on designing microservices. You need to know about the components that you will use to build scalable microservices. But it's not only that. You need to go beyond your technical knowledge. You need to know the rules of this interview. You need to know how to explain how you're going to connect the dots. And you're going to make the right questions to the interviewer to show the interviewer that you know how to communicate well and that you know about cloud services. You know how to organize your ideas. You have to prove in this interview that you're a good problem solver. So that's your main goal. And we're going to be talking here about some strategies you can apply in a practical way to get prepared for this interview, because it's not easy to design a system like in 45 minutes. That's obviously you won't be able to design a perfect system in 45 minutes, but you need to show that you know how to talk about the trade-offs. So if you choose a specific technology to design a system, you have to explain to the interviewer why you did that. The more you do that, the better. So this interview is not easy at all. We need to practice. We need to also study the cloud components that make microservice scalable. And not all the times that you're going to use microservices, but in most cases, in most systems you're going to design, yes, you're going to use the microservices architecture. Okay, so let's talk about some strategies. Let's talk about some points that will definitely help you in this difficult interview. So the first thing, it's a conversation-driven interview, but also you're going to use probably a whiteboard tool where you can put your design. And there will be the phase of you have to clarify the requirements, you need to propose a design, and you need to talk about trade-offs, because everything software, like if you choose one technology over the other, there is a trade-off, and the interviewer will analyze that on you. Like if you say, hey, I'm using Kafka rather than SQS, they're going to ask you, they're going to say, hey, why are you using Kafka? Then you're going to have to explain. And, if you are better on SQS instead of Kafka, just say, hey, I'm going to use SQS. And if they want to go deep into SQS, and sometimes they do in the interview, instead of doing system design interview, they're going to say, okay, tell me more about SQS. And then you're going to have to explain the whole thing. So be careful on the technology you use. And if you choose one technology over the other, explain the reason why this technology is the one you chose. The duration of this interview is usually from 45 minutes to 60 minutes. So it's very quick, right? You have to design a whole system in 45 or 60 minutes. And most of the times on those interviews, they're going to say, it's a very vague statement. They're going to say, hey, design Instagram. Then it's up to you to make the right questions and, talk about like how many users they are expecting for Instagram, and you're going to have to basically collect all the requirements, like the functional and non-functional requirements. And they're going to go especially hard on senior developers on the non-functional requirements. So as a senior developer, they will expect you to talk about the non-functional requirements, and they will expect you also to talk about trade-offs. So why do you choose one technology over the other? Right. So, and also see the interviewer as a partner, right? Because they're going to be helping you in this interview. So they're going to be giving you ideas. It's a collaboration, right? So in this interview, it's also important that you are nice to the interviewer. Sometimes you smile, because when you smile, you make people like you. So do that. I know, Rafael, this is very simple. I know that obviously only this smiling won't give you the job, but it definitely helps, because people want to work with developers who they enjoy working with. So if you show that you're an easygoing person, if you show that you're a nice person to work with, if you show that you're not arrogant, all of those things count a lot. Okay, so this is the first point. And what is the core preparation strategy? So you need to learn about the principles of system design. So you can start with scalability, consistency, and availability. So those concepts are core concepts from when we are using microservice. And we need to learn about the common building blocks such as load balancers, caches, queues, DB partitioning. So all of those things, like almost every system design interview, you're going to be using them. So we're going to have to explain, oh, in this microservice, you're going to use this load balancer because we need to have more performance here. And cache is very common to use as well. And it's also important that you practice designing well-known systems. Like could be Instagram, it's very popular. Could be the URL shortener, chat apps. Like nowadays they might ask you, oh, build ChatGPT. And you're gonna have to come up with the design, right? They're gonna ask you about any popular app. Could be, I don't know, Discord, could be Zoom, could be X, it could be LinkedIn, could be anyone. So it's important that you practice, and there are loads of videos on YouTube, and I highly recommend you to watch as many videos as possible with different systems so that you understand the dynamics of the interview. And then once you understand the dynamics, it's important that you do this interview with a fellow developer. And by the way, you can do that in the Challenger Developer Mentorship. Then it's easy to do this interview. And okay, so you have to do, like I said, it's important to do a mock interview. And, it's important that you have someone who can give you feedback so that you know what are your blind spots. And you could even watch yourself in this interview and, ask questions. So what trade-offs you missed, or if you solved like bottleneck issues. And also before starting a new system, you can ask, what 3 scaling challenges does this system face at the next growth? And obviously, like you don't want to scale very early. You have to ask the interviewer if scaling in a massive way is necessary, because sometimes it's not. And if you are over optimizing, you might be over-engineering, and over-engineering counts as a negative point to you. So you need to collect the requirements and be sure that you are giving a solution that is suitable for this problem. You don't want to over-engineer the solution. That's very important. Assume simple things instead of assuming the complicated features. For example, about Instagram, only talk about the most vital features. Like could be the Instagram feed, could be Instagram story, like basically that, right? Those are the main features of Instagram feed and Instagram stories. You can assume that you're gonna design Instagram only with those features because you have only 45 minutes, only 45 to 60 minutes. So it's not a lot of time, right? So number 3, recommended study resources. So you probably know most of the resources here. So this book is a must read for system design interviews, which is a Designing Data Intensive Applications book. It's a must read for modern systems. So basically you're going to understand how to scale cloud systems, how to design systems that are data intensive, right? And, for all of those high scaling applications such as Instagram, LinkedIn, and Amazon, all of those applications, they are data intensive applications. So this book will teach you how to design, those applications that have, a lot of data and so on. There's also my book, Java System Design Interview Challenger book. And this book, it goes to the components you need to use for a system design interview. So, and there is this very famous book. It's from Alex Shu, System Design Interview. You can get this one as well. There's this other book. But actually, like if you have like those books, it's fine, right? And like if you need to pick one book, I would pick only this one, Designing data-intensive applications. This is the most complete book. Obviously, you can add more, but you don't need to buy lots of books because it's going to be also impossible to read all of them. It needs to be practical, and you need to practice doing mock interviews as well. And you have to remember that it's going to be a process. Like, it won't happen overnight. System design is complex. It takes time. So if you're not used to designing microservices, like, expect that it will be a process. It won't happen overnight. So there is this book, The Art of Scalability. Release it. So all of those books are excellent. And by the way, I'm going to share my mind map with you at the end of this weekly live. Okay. So you have to do something hands-on as well. So you can just build the classic apps, like could be, a chat app, a URL shortener, or could be Instagram, could be Discord, could be X, could be ChatGPT. And you can simply get scalable. So if you've never seen scalable, let me show you here. Scalable. So this is the scalable app. I'm not sure if you can see it. Oh yeah, you can. So just practice yourself, right? And you can even record yourself on Zoom or Google Meets, whatever the app, and you can see how it goes. Obviously, it's better to have the feedback from someone, but this is a start, right? Scalable is a common app and very famous for system design interview. Okay, so let's continue. And okay, I'll put the link of scalable here as well on the mind map. And it's important also that you do some hands-on practicing with AWS or GCP, right? And for Java developers, it's important to read this book, this Java Concurrency in Practice from Brian Go. This, in this book, he goes in depth in some concurrency situations. And yeah, I highly recommend this book. This book is also excellent. And you're going to also practice. So I also recommend you to practice, and like not only designing systems, but you have to also implement those things and see how those things work in practice. So like you can implement those things, caching layers, rate limits, async messaging in Java. You can do all of those things in AWS. So I do recommend you to play around with AWS, create your account, just pay some cents to them. And, the most valuable thing is your knowledge, right? Just practice. Okay, so regarding practice techniques, like I said, do peer mock interviews, pair with developers, and you can be the interviewer. You can interview the other developer. Like I said, you can easily do that in the Challenger Developer Mentorship. And you can also create this one diagram rule where you always start with one high-level diagram. So it could be like client server and DB, and then you start expanding, right? And it's important that you also time box yourself. So like if you are doing a mock interview, like time box that this interview will have like from 45 minutes to 60 minutes. So the main key of this interview is to practice, right? Like once you have the knowledge of how to design cloud systems, then it's a matter of practicing and seeing and checking really, okay, like do I really know how to design a system in 45 minutes or 60 minutes? And use flashcards. So I like Anki. Anki is an app. So let's see here, Anki flashcards. So this is the link, and I recommend you to use that. So you can write the main points of Anki, and you can review them. Like from time to time, you can review them, so that you really absorb the knowledge. And you can also watch all of those. You can find all the designs, all the system design you can imagine on YouTube as well. So you can check, system design for Slack, system design for Netflix, or for whatever the tool. You're going to find it all free on YouTube. So yeah, you need to understand first what's the dynamic of the interview. Because if you don't understand and you go to a real interview, it's going to be really hard, really difficult. Because it's not like, it's something that is kind of unnatural. It's an unnatural interview because like, how would you design a system in 45 or 60 minutes without a strategy? You need the strategy. You need to know how this works. Because you can't have the false expectation that you're going to design a whole system in 60 minutes. That's totally unrealistic. So you need to be strategic here. You need to know how to do this interview. And obviously, you need to design only the main features. And you need to make it very simple. Otherwise, you won't be able to solve it. So interview behavior strategies. So what are them? It's important that you clarify before solving. So the worst thing you can do is to start like designing everything without asking, right? Like this is a huge red flag. And it's very likely that if you do that, you're going to be rejected right away because they're going to assume that you're not a good problem solver. Like if you jump to the solution right away without asking questions, they're going to say, oh, this guy he doesn't know what he's doing, right? So always clarify before solving. So ask load assumptions, ask about users, data size, consistency requirements, failure tolerance, and think out loud. So this is important also for the coding interview. So while you're coding, you need to talk right? So, and you have to verbalize trade-offs. That's very important. This is even more important as a senior software engineer, because for every technology you choose, there's always a trade-off. And the interviewer is expecting you to know what is this trade-off. And don't use tech buzzwords. Start with simple solutions and scale step by step, and be wise on the technology you choose. Don't choose technology that you're not used to. Because what they will do, they might counter you. They might say, hey, you said this technology. You talked about Kafka. How much do you know about Kafka? And then you're going to be challenged during the interview. You're going to have to explain the whole thing about Kafka. So, like if you're not very good with Kafka, don't use Kafka as an example. Like you can use SQS, for example. And SQS has a much lower learning curve than Kafka. So always go to the tool that you're more familiar with, but at the same time, make sure that this tool will solve the problem, right? And also admit gaps honestly. So it's better to say that one option is X, but I'm less familiar with Y, so with another technology. And yeah, always like in the interview, it's better to be honest rather than, trying to say things rather that are not true, right? Because if you're not honest, you're going to have to make up things. And like if you're lying during an interview, that's a huge red flag. Like it's a reason to be rejected, a very strong reason. And in the interview, like it's very easy to get if you are lying or not. Like just make questions about this technology. And if you don't know how to answer, like it's better to say that, okay, I don't know this. But like I said, it's better to, not even enter on those details and just say a technology that you know. Or you don't need to know everything, because obviously it's impossible. How many components do we have for system design? There's so many. But you need to know the fundamentals and the most important components. That's for sure. And you have to have a collaborative tone. And, the interviewer is your colleague, is your partner during the interview. And be open for feedback. And you can even ask for feedback directly. You can say, hey, at this point, I see two paths. Which do you think is more relevant for our scale? You can ask that, and also end with evolution. So always conclude how the system could evolve at the next scale. So like if you know how to evolve the system at the next scale, tell at the end of the interview, say, hey, interviewer, so this is the first version of the system, but if we wanted to scale the system 10x, we would do this. We would follow this strategy, right? Because if you end like that, it shows that you know how to scale a system, and they want to see if you know how to scale microservices, right? So that's an extra point for you during a system design interview. Okay, so this is the point 5, and on point 6. So this is more focused on the senior level. So for the senior level, they want to know the depth of your knowledge for detecting failures. So like you can study cases from AWS and Google Spanner papers. So basically you need to know how to handle those failures, because it's a fact that when we are working with microservices, they will fail, right? So The more you can explain that you know how to handle cloud services failures, the better for you. And regarding integration patterns, learn about sagas, CQRS, event sourcing, and also be ready to discuss them. So if a discussion come up during the interview, it's important that you know how to discuss all of those patterns, right? And you need to talk about costs, and you need to know like what are the trade-offs of choosing one technology over the other. Like you need to talk, okay, this technology will be more expensive. Let's use the other one that's cheaper. So you need to have this in mind. As a senior developer, they're expecting you this knowledge, right? And like they always expect you distributed job expertise. So you can talk about JVM, tuning, thread pool serialization. If you're able to discuss about those things as a Java developer, this will definitely give you extra points. So the key strategy to be ready for the system design interview is to, treat the preparation like going to the gym, right? If you go to the gym once a week, it doesn't really matter. Like you don't grow. Like it's the same as nothing. But if you do the gym like every day, 30 minutes, man, you're gonna grow. You're gonna be transformed in a couple of months. And with any skill we are developing, like the skill of system design, so we can apply the same principle. It's very important that you do short daily drills, like could be 30 minutes a day, and you can pick a system and you can draw a scaling solution, and during the weekend you can do a mock interview or you can create a project, and with some time you're going to see your improvement happening. And this is called deliberate practice. And if you didn't watch the session I created about that, it's one of the weekly lives. I think it was like one live before the previous one. So and this is proved scientifically. This is what the champions of the world do, like the very best in the world. What they do, they practice their skills deliberately. So what does that mean? They practice the skills they need to be successful, right? They practice those skills consistently, because it's funny the way we learn. We actually learn things when we sleep, and this is proved scientifically. Why? Because when we sleep, we activate our long-term memory, right? And if we practice something consistently, we also activate neuroplasticity, which is something that happens in our brains, that the form of our brain changes, and it makes it easier for us to learn new things. And also in the deliberate practicing presentation I did before, I show you the difference of studying one Saturday, 10 hours is a lot, right? We get exhausted, rather than studying 25 minutes every day. The difference is exponential. If you study 25 minutes every day, your growth is it's absurdly higher than if you study very intensively only one day in the week. So this works. This is scientifically proved. So if you practice a little bit every day, there's no doubt you're going to improve. Okay, and what are the common mistakes Java developers make in a system design interview? Let's see here. So by avoiding those mistakes, it will definitely enhance your chances to passing in this interview. So let's see here. I'll just minimize them. Okay, so the first mistake is over-focusing on low-level Java details. So what are them? So for example, if you dive into thread pools, garbage collector tuning, synchronize versus volatile too early, like those are very granular details. Like sometimes it's irrelevant for system design interviews. So yeah, like I said, this hurts very badly because the interviewer is expecting you to do a high level design rather than coding, right? All of those things are mostly coding, right? The way to fix that is to stick to system abstractions like cache, DBQ, and only bring the JVM if they bring up if they tell you, oh, tell me about the JVM. But usually you don't need to mention about JVM during system design interview. Treating the other mistake is to treat system design interview like a coding problem. Designing classes, methods, or writing pseudocode. So that's a big mistake, and it could be a huge red flag. You could be rejected right away only with this mistake. And this hurts because you have 45 to 60 minutes to design the system. So you don't have time to code. You have the time only to design the system in a very high level. So this hurts because you're going to waste your time. You're going to miss the expectation from the interviewer. And remember that you are creating a design of the system. You're not creating code, right? So, and the fix is basically to focus on components, flows, and trade-offs. And yeah, you wouldn't need to use coding most times. And the third is skipping clarification questions. So that's a big mistake. And only this one might get you rejected right away. Like if you jump straight into design without asking about scale constraints or priorities, they might reject you right in the beginning of the interview, and that's really bad. And this hurts because you might design something that is completely wrong, right? And the fix is to start with clarifier, to ask questions, right? You can ask, what's the expected traffic, or is consistency or availability more important here? So ask those questions so that you know what to design. And the other mistake is over-normalizing database design. And you're going to spend a good amount of time, right, only to normalize the database. And that's not the goal at all. The goal is to see if you can design a system in a high level. You don't need to normalize the whole database, right? And if you focus too much on normalizing database, you're going to miss the important stuff in the system design interview, which is, caching, partitioning, durability discussions. And the fix is, you pivot to the system design, right? You don't waste your time talking about normalization of a database, and you talk about scaling strategies, indexes, shards, replicas. Like those things make a whole lot of a difference in a system design interview, because that has everything to do with scaling system. So the other thing is to ignore APIs and contracts. So the mistake is to talk only about data flow, forgetting client-facing APIs. And why this hurts is because, system design is architecture and interface. The APIs will only prove that you can connect business to business needs to design. It doesn't mean, does that mean that you can't create an API? No, you can create the endpoints, but you don't need to overdo. You don't need to, explain all parameters you're going to receive. Just create something very simple. Say, hey, this is the API, it's a post API, and that's it. Very high level, right? And you can define 2 or 3 core endpoints, and don't overdo. Don't put lots of details on the APIs. The APIs are necessary to create during the interview, but you don't need to put a lot of details on them. Okay? Forgetting trade-offs, and that's a very serious one. Only this one might get you rejected as a senior software engineer. So for example, you can say, I'll use Kafka, or I will charge the DB without explaining why. So this is a big mistake. You have to explain why you're using Kafka or why you're charging the database. And if you do that, if you don't explain why, it will show that you can name tools, but you can't explain them. So you're going to look like a shallow developer who doesn't know about those tools. And the fix is to, in every choice, you explicitly state 1 or 2 alternatives and the trade-off. And if you don't know any alternative, it's okay. At least explain why you chose this option, right? For example, you could say, I'll start with SQL for joins, but NoSQL would reduce write bottlenecks at scale, right? So, okay, number 7 is jumping into complexity too early. So what is that? So the mistake is to design for a global scale before a simple working solution. And why this hurts? So, and by the way, I always ask the interviewer if they want something very complicated. And why this hurts is because it looks like over-engineering, and the interviewer also loses track. And the fix for that is to follow a two-phase approach. So you can say, hey, this is the version 1, this is the simplest version. I want to create something very simple. And then at the end of the interview, you can say, hey, by the way, to scale this system 10x, we could do this, right? Just to show the interviewer that you know how to scale the system. Mistake number 8 is weak communication style. So the mistake is to talk in monologues, or you could even be drawing the design without saying anything, and that's a big mistake. Like while you are drawing your design, you need to explain to the interviewer, hey, like I'm doing this, and explain the why you're using that solution. And the thing is that why it hurts is because the interviewer won't be able to follow your thinking, right? And that also, and only this itself, only this mistake you're gonna be rejected as well. If you don't communicate about what you're drawing, that's a big red flag. So this is one of the mistakes that will count a lot. If you make this mistake, the chances are very high that you won't pass in the interview. So what is the fix? It's simple. Just narrate your thought process. And this is also valid for the coding interview challenge, right? So clarify the scope, talk about the high level components, talk about bottlenecks and trade-offs, API and schema, and scaling evolution, right? So regarding the schema, it could be something very simple. Like I said before, you don't need to normalize this database. It just needs to be something very high level so that you show that you have the capacity of designing a system in 60 minutes. But obviously it has to be simple. Simple and effective. It has to work as well. Okay, so obviously when I say has to work, like it's metaphorically, like obviously it's not a real system, right? It's just a design. But if you put that in practice, it should work, right? So the other mistake is underestimating non-functional requirements. And as a senior developer, this is quite heavy. So the mistake is to focus only on functional requirements such as crude API while skipping latency, availability, cost, reliability. So this hurts a lot, especially for senior developers, because, from senior developers, they are expecting that you know how to create highly available microservices, and you also know how to reduce latency between microservices. You know how to reduce cost. You know how to make microservices more reliable. So always ask questions about SLAs. So ask to the interviewer, what are the SLAs, which is a service level agreement, right? So what the user is expecting from that, and explicitly discuss latency targets, replication targets, and monitoring. So all of those things will show that you are a senior software engineer. And the last mistake is not ending with evolution. So the mistake is to stop at the first working design. And why this hurts? It's because you miss the chance to show knowledge as a senior software engineer, right? And the fix for that is to say, hey, at 10x scale, I would charge the database by user ID or something like that. And you can say, oh, we would add caching validation strategies to minimize staleness. So always end the interview with this 10x evolution, right? And to end this weekly live, so what interviews actually look for? So what are the fundamentals of the system design interview? The fundamentals are that you need to structure your reasoning, right? So basically, can you break down a vague problem? And that's basically what they are doing, right? Because they're going to say, oh, design Instagram. And you have to, break down a very vague problem. And you have to ask questions, and you have also to talk about the trade-offs, and you have to show that you are aware of the cost of the trade-offs. So you have to be able to explain why you would choose SQL versus NoSQL, right? And you have also to have clarity on your communication. So basically, this is a very important skill to collaborate with your teammates as well, and have practical judgment. So do you avoid, complicated tools Or, do you start over engineering, or do you start with the practical and, the technology that will work? So they will evaluate that on you. Like if you over engineer things, or if you give the solution that will work, that will be effective to the problem, right? And growth thinking. So how can you evolve the system at 10x scale, right? So all of those things will count a lot for your system design interview, right? Very good. So let me go back here. So that's pretty much it. Thanks everyone for being here. Congratulations on focusing on your career. And I'll see you next Tuesday at 10 p.m. London time. Okay, so cheers. Thank you so much.